Hello friends, this will be a short video on programming concepts like classes, objects, attributes, methods, decorators, special methods in a class. I will help you to visualize the objects getting instantiated using a class. Also, when different methods are applied, how the attributes gets changed. And I'll be doing it by building an endless scroller window for a game. Let me show you the output. The output will be like this. In this case, different layers of images are stacked on top of each other and they are moving at different speeds to give this a beautiful parallax effect. A parallax effect is something where the background and foreground moves at different speed. So let's begin. I'll be using the pygame module. So I'll be importing pygame. Then I'll be defining two variables, which is screen width and let's say screen height. This is the width and height of the game window on which the objects will get rendered. Then we'll define frame rate per second, that is 60. Then I'll define a clock, that is pygame.time.clock. This will help us to control the frame rate. Then I'll define a screen, that is the pygame window on which we are going to render the objects or the images or sprites. So this accepts a tuple, which is the screen width and screen height. Then I'll initialize all the modules of pygame by using the pygame.init. I'll specify a boolean variable, run true. So this will help us to get into an infinite loop, and the changes which we are going to make to the sprites will be reflected while we go through this infinite loop. We'll be collecting all the events. Those are the interaction between the user and the pygame window, so that we can terminate the game or take the user's input. And if the user presses something like the cross button on the window, so that will be a pygame.quit event. Then we'll be assigning this run variable as false and will break out of the loop. And every time you need to update this screen so that whatever changes you make gets reflected on the screen. And also you can name the window so that it looks nice. Not necessary, I'm just naming it Forest Shooter. So let's run this file, and this is the game window. So let us load an image, and I'll be using pygame.image.load, and I have a set of images which I'll be using for this video, and I'm defining them over here. I'll be using one of them right now, and let us use the screen.blit method to render the image on the pygame screen. And the first argument is the image to blit, and the second argument will be the start coordinate, means the starting coordinate on the screen. So if we just press the run button, we'll get the image on the top left corner, and the size is a little smaller. So what we are going to do is we are going to transform it to the scale of the game window. So that's it. If we now run it, we'll get the full scale image. Now what we want to do is drag or scroll the image towards the left or right. So let us initialize a variable, that is start, and we will be inside this loop. We are going to change the position of the start at, let's say, by 4 coordinates. So let's see what happens. The image is getting dragged towards the left, but the thing which you are seeing now, it's like an empty window. It is the trail left over by the previous image, which has already gone past to the left. So I'll control the speed by using this clock.tick to 60 frames per second. Now it will be a little slower, you can see it. So what we need to do is we need to draw a set of image at 0, 0 and the next set of image at the screen width, which is 1200 at present. Now when this black image, the bordered black image, will scroll towards the left, the red image will occupy or will fill up the space which is left over by this set of image. So what will happen, you don't get those trails, and we'll have to keep a check that when the left coordinate, that is the start point, passes over the screen width, it is greater than the screen width, we'll have to reset the entire set of two images to 0, 0. So how we are going to do this? And if you don't get this the first time, please watch the video again and again, and I'm sure you will get it. So we are going to make a check for this start variable, that if the absolute value of the start is greater than the screen width, then we are going to set it back to 0. So let's see what happens. When we run this, we see that the image is getting dragged towards the left, and when the left coordinate, the end coordinate passes this, then it is again resetted back. So what we need to do is that we have to draw a second set of image just back to back, so that we don't get these trails of images from the first one. Okay, so once it passes the 1200 coordinate, the left image, then the entire thing will get resetted to 0. I hope you get it now. So I'll just draw two set of images. I just copied the command by using Control D in your PyCharm, if you're using PyCharm. Now if you see what will happen, you will see an endless running background, and this will run endlessly. You can use it for your game, but it's quite boring. So what we are going to do is, like, we'll stack a set of or layers of images on top of each other, and how we are going to do is using object-oriented programming. So let us import the module pygame on, and also I'll be using the data classes decorator. So what is the work of a decorator? Means a decorator just adds some extra functionality to a class or to a function. In this case, this decorator will help us to override the init method. I'll show you in a minute. So it will give us some extra functionality also. I will also call the field module, and the things which we need is the path. This is the path to the image which we will be using for the layer, and it should be a type string. Then we should pass over the screen width. That should be something integer type. Then screen height, that should be integer type. And the start position, which should be something like integer type. And I will initialize it to 0. Then we'll have to pass a pygame image, and this attribute we would not specify. We would not like to specify at the init time. We would specify it after the object gets instantiated. So we are going to use this field module and specify that the init should be false. So you don't need to provide this while creating the object, and we'll be calling the post-init method. It is a special method which is used in class, and this got called automatically when you instantiate an object. You don't need to call it. So what we are doing with this method is we are going to load the image, pygame.image.load, and provide the path to it. So that's it. And also we'll rescale it using the transform module, and that will be something like self.image and self.screen width, self.screen height. That's it. Now we need to define an update method to update the value of the start position, and let's say the start is changed by the 4 coordinates which we have done earlier. Also we need to check that if the self.start is greater than the width of the screen, then reset it back to 0. And finally the draw method, which will draw the images on the screen and will pass a screen argument, which is the pygame window. And like the last time, we just need to blit the image. Same syntax. It will start at the 0 coordinate, and the y coordinate will be obviously 0. We need a second set because I've already shown you to prevent those trails, and this should start at screen width. That's it. Now we're not going to need this, not this either, not this either, and I'll be deleting this. So that's the benefit of the class. We can write clean code. And to load the images, I'll write one set of function, load images, and here we are going to instantiate the objects, but prior to this I need to call the layer class from the layer script, and here I'm going to initialize the objects. So what it needs is the path. Second thing is needs the screen width, screen height, and I'm going to duplicate this command 4 times because I have 4 set of layers, 4 set of images, and just rename them. Also, I need to rename this path, and I need to return this in a list. So that's it. And also I need to call this function to load the layer list. That's it. Now the next thing is we need to just iterate over the layer list, and we'll have to call the update method, which will be updating the position of the start coordinate, and we'll have to call the draw method with the screen argument. Now let's see what happens. So we can see that a set of images stacked on top of one another has been drawn on the screen, but the performance is very bad, or it's very poor. You can see it's like means the speed is very less. So some of them will think that we can increase the speed to, let's say, 10, and we can see good performance. But still, that's a little messy. So what we can do, I have identified something. There is something called convert alpha, which controls the opacity of the image, but using it, we can see that there is an improvement in the movement of the layers. You can see it over here. But the thing which we have obtained right now is like all the layers are stacked on top of each other and they are moving at the same speed. But we don't want this. We need a 3D looking background like the parallax effect, which is like a little lively. So what we are going to do is using this oops concept. It's very easy. And I'm going to modify something like the screen width and screen height. We don't need to instantiate it. It should be, we can state it as a class variable. So from typing, I'll import the class variable and we'll specify it in this way that it is an integer type, and I'm setting it to 1200. And the next thing is screen height, which will be set it to 400. Also, to make so that we can see the parallax effect, I need another attribute like the speed modifier. So the speed modifier is something which will change the coordinates of the start position. So it will be something like integer type. Now what we need to do is remove all this. Let's say I'll provide something like 1 for the first layer, the speed will be 3 for the second, 5 for the third, and let's say 7 for the fourth. Now I have improved a little bit, means I've changed these 2 lines. It will be a class variable, so we don't need to define it over here. While instantiating the object, this is a little easy. Now we need to specify the path of the images and the speed modifier. So let's see what happens to the output. So it's still moving at the same speed. Yes, I need to change this part. Like when I'm updating the start coordinate, it should be changed by speed modifier so that all the screens or all the layers are moving at different speed. So if we look at the output now, it would be something like the one we desired from the very beginning, like the parallax effect. So in this case, what happens? The front trees, the lights, the middle trees, and the back trees, all of them are layers, and these layers are stacked on top of each other, but they are moving at different speeds. So we are getting this beautiful looking parallax effect. So if you like it, please comment or like the video to support me. And if you need this set of images to practice, then please comment on the video and I'll be happy to provide all those things. The code is already provided to you. Thank you. Thanks a lot.